Welcome back. So today we're starting section 8, the last section of chapter 2. And in this section of learning target, we're going to be talking about graphing two variable inequalities. Okay, so let's take a look. So a linear inequality is a two variable inequality whose graph is a region of the coordinate plane bounded by a line. Solutions to linear equations are represented by a shaded region. Okay, so in these examples, if you look right here, the solution region is that yellow half plane. Okay, so the shaded region is your actual solution. And then you also have to look at the boundary line. You have to decide if your boundary should be solid or dashed. Solid means the line is part of the solution. Dashed means the line is not part of your solution. All right, so try linear inequalities. First, you need the equation in y equals mx plus b form. And we discussed this back in section 2.3 also, right? The only way to graph lines is if it's in y equals mx plus b form. And then you have some decisions to make. Okay, so the line is dashed if it's strictly greater or strictly less than. So if the line is not part of your solution, dash it. And make it solid if it is part of your solution, okay? And that's very similar to, remember, we had open circle, closed circle when we were doing one variable inequalities. Same idea, except dashed or solid instead of open or closed, okay? But again, same idea. Then in terms of shading, shade above if it's greater than, underneath or below if it's less than. And I think that's pretty self-explanatory. I haven't really had kids mess that one up, right? Pretty self-explanatory if it's up or it's down, less than or greater than. So let's dive into actual graphing then, okay? Because that's going to be the bulk of our lesson, to graph these things. So looking at this, again, whenever you're graphing, start at your y-intercept. So I'm going to start down at that -1, then slope of 3 over 1. So up 3 over 1, up 3 over 1. And this is why we took so much time practicing graphing earlier, because I don't want to have to focus on that now, okay? Hopefully you're already really good at graphing. So now I need to determine if it is a solid or dashed line, okay? So for that, I'm going to look here. It is less than or equal to, okay? That or equal to piece, that bar underneath it, that is what makes this a solid line, okay? So again, it's because of the or equal to bit, or because of the bar underneath the inequality, that makes it a solid line. Now I also look at the inequality and see that y is less than my line. Less than meaning underneath. So I'm going to shade the underneath area of my line. Okay, and that is my solution region. And I'm done. All right, what about this next one? So again, start at the y-intercept. So start up at 7. Slope -1/2. So down 1 over 2, down 1 over 2, down 1 over 2, so on and so forth. All right, now I look at my inequality. So here I have strictly greater than, okay? It does not have that or equal to piece, so that means I am dashing my line, okay? Strictly less than or strictly greater than means you should be dashing it for me, okay? And this time it's greater than, so I should be shading above my line. And now you're done. All right, so now let's take a look at some more of our unique examples, okay? So for example, this one, x is greater than 4. So it is important that you remember your special case lines. Remember, X is going to make a vertical line always. Okay, so vertical line strictly greater than means it's going to be dashed. So a dashed vertical line at 4. Now, where is greater than it? Well, greater than would be when x could be 5 or 6 or 7. So that's represented in this region over here. Here are where all the x values greater than 4 are. And then that would be it. Okay, so again, also remember your special case situations here in order to graph those. And finally, what about this last one? So this last one isn't written in slope-intercept form. So now I need to get it into slope-intercept form before I can graph it. So I'm going to add the 3x over. I'm going to divide by 2. And now that's the inequality that I want to graph, okay? So also don't forget that skill, which was also covered back in section 2.3. So you can see a lot of connections between this and what I spent time with on 2.3 with you, because I needed you good at graphing lines, so you could be good at it when you get to this point here. So remember, start up at your y-intercept, slope of 3/2. So up 3 over 2, up 3 over 2, and then the exact same in the reverse. It's less than or equal to, okay, I'm seeing that, looking at that, it does have the or equal to piece, so I can make this a solid line, and it is less than, so I'm going to shade the underneath part, just like that, okay, and now I'm finished. So do make sure you know these two are probably the most important cases to know. The first slide was kind of just a precursor into this. So if you can graph these, you're in good shape if you know what to do for them, okay? Because they encompass the skills from the previous page already. Now what about here? Writing an inequality, okay? So to write an inequality means that you have to be able to first figure out the equation of the line and then interpret what that inequality symbol should look like. So here, let's take a look at this. So I see a point right here and a point right there, okay? So to graph it, you want to first identify 2 points that are on actual grid lines, okay? Because what it's helping me see is my slope, up 3 over 1. So my slope is 3, and my y-intercept is down at -1. Okay, so I have my equation, 3x minus 1, but now I have to determine the direction and um, if it's equal to or less or not equal to. So here I see the graph underneath my line. So underneath my line would be less than. And then it is a dashed line, so it does not get the or equal to piece, okay? This one I just have to leave as is. Now what about this next one? So again, first, let's identify 2 points on the graph. Now here, I see 2 points right there. So for this one, I'm seeing down 1 over 1. So I'm seeing a slope of -1. And my y-intercept looks like it's down at -6. Now, once again, it looks like my shading is below my line, so I'm going to use less than, but my line is solid. So because my line is solid, I am going to include that or equal to piece with it. Okay? And now both of these are finished. So again, to write the inequality, basically, find the equation of the line, then interpret where's my shading and is my line solid or dashed. Those are the three things you have to consider when you're creating the inequality itself. Okay? So lastly, what would notes be without a word problem? Okay? So do this word problem and then we'll wrap up. So you're going to the fair to go on the rides. You don't want to spend more than $15. And here's a couple things that you know. You know tickets are 25 cents each. Small rides require 3 tickets, and large rides require 5 tickets. How many small or large rides can you ride? All right. So here we're talking about cost of rides, okay? So here I'm going to let X represent small rides, Y represent large rides, okay? So my number of small rides, number of large rides. So if I'm talking about cost, how much does it cost to go on a small ride? Well, small rides are 3 tickets, each 25 cents, okay? So the cost of a small ride is going to be 75 cents, okay? Each ticket is 75 cents. Well, what about a large ride? Well, a large ride is 5 tickets, each at 25 cents. So a large ride is going to be $1.25. So right now, that's representing my cost, okay, my total cost. And what do I know? Well, I don't want to spend more than $15. So I can spend less than or equal to $15. All right, so now I have my inequality expressing how many of each ride I can go on and how much money it is. All right, so if I want to graph it now, well, remember the only way to graph is to get it into y-intercept form, or slope-intercept form, sorry. So I'm going to subtract off that 0.75x. Then I'm going to divide everything by 1.25. So negative 0.75 divided by negative 1.25, that's going to be 0.6 or 3/5 x. Okay, same thing. And then 15 divided by 1.25 is going to be 12. So now I have the y by itself. So let's work on graphing this. So I have a y-intercept of 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then a slope of 3/5. So up 3 over 5. Up 3 over 5. And I need less than or equal to. Or equal to means it is a solid line. Less than means I'm shading down here. Now, a couple of observations on this. One, I'm only showing the first quadrant. Why might I only be showing the first quadrant? Well, I'm hoping pretty quickly you can see it doesn't make sense to have negative values because this is the number of small rides I can go on. This is representing number of large rides I can go on. So it doesn't really make sense to have negative values. So that's why I can get away with only showing the first quadrant. Okay, and now the cool thing is I can pick out some particular solutions. So here, for example, I could pick this point right here. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I could go on 7 small, 15 large. I have enough money for that, okay? I could go on this many. I could go on 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. I could go on 17 small and on 2 large. So basically, any point that's in that shaded region is giving you a combination of amounts of rides you could go on and afford. Okay, so that's kind of a really cool thing you can do is any point in that shaded region is a possible combination for a solution. Okay, just really cool, something I wanted you to notice. So thank you so much for joining me for this. So once again, please make sure that you write your summary for me and then come back ready to do your practice work.